Hello and welcome to another one of my Leetcode videos. In this one we'll do Leetcode 1235. It is a hard problem. It says maximum profit in job scheduling. So basically we're given a set of jobs, right? And for each job we have a start time, an end time, and a profit. So this one says 1 3 50. This one is from 3 to 6 70. This one up here is from 2 to 4 and the profit is 10 and so on. So 1 3 50, 2 4 10, that's this one up here, and so on. And so what we have to do is we have to schedule these jobs for the max profit, but we can't have overlapping jobs, right? So in this case, like if we pick this job 50 and 70 and drop these two, we maximize our profit because it's 120. Let's say if we executed this job up here, we can't execute any of these two because, or this one on top, because they're all overlapping, so we'll only have a profit of 10. And then if let's say we executed this job number 40, we can't execute these other two, and so we would have a profit of 90 because we'd execute the first one and this one. And so our objective is to maximize our profit. So what will be our approach to solve this problem? So the first thing to note is that with any of these like interval kind of questions, sorting it is usually a good idea, because once we sort the array, we can know that everything that's later, cannot be starting before the current element, right? So let's first sort these jobs and then see what we get. So this is our sorted jobs array, and what I've done is I've written it in the format of start, end, and profit. So for each job, we sorted by start time, right? So we have 1 to 3, 2 to 4, 3 to 4, and 3 to 6. These are the 4 jobs here in this example. And so now that we've sorted them, how do we go about and find the maximum profit? So we can think of this as a dynamic programming problem, right? Because in order to, this involves exploring a lot of combinations, permutations, and it also involves maximizing our profit. So in order to, solve these type of problems, we usually want to, not duplicate work, not do redundant work, and find the maximum possible outcome, right? So let's come up with a mathematical model, right? So where if we start at index I, right? Let's say this is index 0, index 1, and so on. So if we start at index I, what is our max profit, right? So this means that ignoring everything else before I, if we just start from I to the end, what will be our max profit, right? So in this case, our max profit will be the maximum of, we have two options, right? So option one is we skip the current job. And then option two is basically we take the current job, right? But then if we take the current job, we can't take any other job that overlaps with it, right? So let's say if we take this job, the next job we can take is at this index. We can't take this job over here at index 2, right? So basically, if we write this out in more formal terms, if we skip the current job, the profit is just going to be max profit of I plus 1, right? Because we skipped the current job. And option 2 is if we take the current job, we get the profit of the current job, so it'll be the profit of the ith job plus the max profit of the next non-overlapping index, right? So if we take the ith job, then we need to find the next non-overlapping index and then find the max profit starting from that index, right? So in this case, let's say if our I was 0, we have two options. Either we skip I altogether and then we find the max profit of this one, or we take I and then we find the max profit of the next non-overlapping index. So what is, since this ith job ends at 3, right, our next non-overlapping index is the first index that's greater than or equal to 3 in the start time. So that's this one, and conveniently our start array is sorted, so we can easily, locate that index. And so with given this mathematical model, now let's look at some base cases, right? So our max profit of, like n, which is jobs.length, is 0, right? Because if you, this is a 0 indexed array, right? So this is index 0, 1, 2, 3, right? And so index 4 is basically the end of the array, which is non-existent. So basically, if we skip all of the jobs, our max profit of n is 0, right? And we know that our max profit of n minus 1, which is basically the last index, right? So meaning if we ignore everything before it, if we only have the last index, for that we know that the max profit is pretty much equal to 70, right? Because, or the profit at n minus 1, because if there's only one job, you might as well take that job, right? Because there's nothing else that can overlap with it. So with this mathematical model, now we know that we can use dynamic programming and memoization to compute the max profit for each index, and at the end we just return max profit at 0. So let's go ahead and code the solution. Okay, so the first thing we need to do is we need to be able to put these data in this form, and then sort them, right? So let's go ahead and create our merged array, which will be a 2D array of start time dot length, and then we'll just iterate through and add them to our merged array. So here we have our loop, and now we're just going to set the merged at I to an array containing all of these. So I've gone ahead and done that. We have created our merged array with start time, end time, and profit, like the format that's shown over here. Then we just need to sort this array by start time. So there we go. I've gone ahead and sorted that merged array by start time. So we're, for each entry in this array, which is also another array like that looks like this, we're comparing A0 and B0, which is basically start time. So now that we've sorted the array, let's go ahead and create our max profit array, which will contain the max profit at each index. So that's our max profit array, and we actually need the length to be +1 of merge.length, because for convenience we'd like to index this n, which is equal to the length, in the array as well. And by default everything has a value of 0, so we don't need to do anything special to get this functionality. And so now what we want to do is we actually want to loop through the array in reverse, because if you noticed here, our equation for max profit at I depends on just the future indexes of max profit, right? So our I depends on I plus 1 and the next non-overlapping, which is also in the future. So if we start from the last one and go backwards, we know that we'll always have our max profit computed for all future indexes, right? So let's go ahead and create a loop to compute those. So I've gone ahead and created this for loop, which will start from start time dot length minus 1, which is basically going to be like this index, and then up to 0, and then we want I minus minus, so it goes backwards. And so now what we want to do is simply compute max profit at I is equal to, we'll just basically copy this formula. So I've gone ahead and done that, and we'll come to calculating this in 1 second, but just to close this off at the end, we want to return max profit 0. So now the question is, how do we compute the next non-overlapping index? So since we're going backwards, right, let's say we have 3 and 6, right, and then we come here to 3 and 4, the next non-overlapping index will basically be the first or the earliest one in the future that starts on or after 4, right? So in this case, nothing starts on or after 4, so basically it's going to be the next non-overlapping index will be just n, where our profit is 0. And then in this case, let's say it's 1 and 3, the next non-overlapping index here would be this one, right? Would be index 2, because this 0, 1, 2, the second index in this array, because it starts at 3, right? So the next non-overlapping index is basically we look up the end time in the part of the array that we've already seen. And since this is already sorted, we can put it in something like a tree map and look up the end time, right? So if we use a tree map and the key of the tree map is the start time and the value is the index, then we can look up the ceiling of the tree map with the end time of the element we're on. So let's say in this case the end time is 3. We look up the ceiling of the tree map, so we'll get anything that's greater than or equal to 3, and we find this one, right? And so this one is at index 2, so we'll know that the next non-overlapping index for this is 2. And since the array is sorted, we can use a tree map and do this in log n time. So let's initialize our tree map, and we need to make sure we update this tree map every time. So I've inserted this one. Merged I is 0 is basically our start, because that's what we put here. And the I over here is the index. And actually I realized here we're missing this profit I plus. So over here we need to put merged I2, which is what our profit will be, right? And that will basically be the second term if we choose to take this element. Yeah, so moving on, I've updated the start time to index with the start time and the index. And here now what we just basically need to say is, okay, integer of the next non-overlapping index is basically the start time to index dot ceiling entry of our current end time. So our end time is going to be merged I1, right? Because we put the end time in the 1th position of the sorted array. So now this is going to be our next non-overlapping index, but then we might not have an entry that's actually greater than equal to the end time. In that case, we want to fall back to n as we indicated here. So I'll just go ahead and write that real quick. So I've gone ahead and written that. So we have here optional of nullable the ceiling entry. So if we find a ceiling entry, we get its value, because the value will represent the index, since this is start time to index. Otherwise, we fall back to start time dot length, which is basically our n here, and it'll give us a profit of 0. And this if it's null, it basically means that everything after that index is overlapping, and so the profit of taking it will be 0. So I believe this will do it. Let's go ahead and run the code and see how it does. Oh, we need to maybe just get rid of this and see how that works. Okay, and here we need to specify the length of the array, so 3, because we have 3 things. Cool. We passed the test cases. Let's submit. Perfect. Thank you so much for watching. I'll see you on the next one. Cheers.